Hey everyone, it's Steven here. Today I have Luke, who works at Nomad. He's one of the engineering leads at Nomad, building out a really innovative bridge solution for startups. And they also are building out their own bridges. You could play around with it. They partner with Connects, I believe, right? Is that correct, Luke?
Yeah.
On the bridge. So yeah, check them out. And then today we're just going to go more into like the technical implementation of bridges and explain some of that because I've been getting a lot of questions regarding some of the bridges from my previous videos. So I thought I'd bring on Luke, who's really like innovating in this space. And yeah, so thanks for joining, Luke. And yeah.
No, thank you so much for having me on. I appreciate you reaching out, and excited to chat more about bridges and a little bit about Nomad. And yeah.
Yeah, for sure. Yeah, thanks for hopping on as well. I guess like what maybe we could get into a little bit of your background. Like how did you kind of get into this space and what got you excited about bridges? Yeah,
sure.
Particularly with Nomad.
Yeah, so I got into crypto maybe around 2.5 years ago. I was actually still an undergrad at Stanford at the time, but there's a professor here. His name is Dan Bonet. He's a pretty well-known cryptography professor, also an advisor to A16Z crypto. So he's, pretty in and about in the space. And so I actually read a textbook that was in his class and took his class as well. That's kind of how I got into crypto initially. Kind of around that same time, I joined Celo, the kind of like layer one focused on with a stable coin and focused on more developing countries, and then kind of stayed there for about a year and then went on to Nomad. So that's kind of the short story of how I've gotten to where I am now.
Gotcha. Very cool. And then was like bridging something that you kind of did, was kind of interested in before Nomad? I was kind of curious, like, did you kind of look at like the whole relayer scene and saw that it was like somewhat could be a space to improve, and was curious like what? Yeah.
Yeah, no, that's a good question. I think when I first started getting into crypto, like one question that I really remember like vividly circling around, especially at like the conferences, like kind of 2020, 2021, was like, everyone was like, oh, like what is the layer one that's gonna like win out in the end? Like who's like the phrase ETH killer was still something that was flying around. And for me, I don't know, I mean, I grappled with this question as well, but I think the fact that interoperability is kind of made this world possible where we have multiple chains, it's very difficult to encapsulate, the same purposes, community, and like traits that you could want in any kind of chain in like one place. And so for me, it was always interesting in that we could have like a kind of multi-chain world which represented different use cases and different communities. And yeah, that's one thing that always drew me to interoperability particularly.
Gotcha, for sure. Yeah, I've also, I think I mentioned it before, I also like tested out like building some bridges just to kind of wrap my head around this space. I'm kind of curious, like maybe like just kind of digging into like your Nomad's approach to bridges, and then like kind of how you see bridging in the general ecosystem. Like there's a bunch of approaches. Like I was an early user of a lot of the early bridges, like Wormhole, AnySwap, Connects, the early Connects one before they even had the UI change. Yeah, so it's kind of curious, like how do you see the space right now, and what do you think the future might be, and then what you are also working on at Nomad?
Yeah. Okay. Yeah. No, that's a good question. I think that's a good starting point as well. It's a bit of a long stretch, I guess, but I think one thing that's kind of been missing in the space is like the concept of like what is a good bridge versus a bad bridge. Like you mentioned some of the earlier bridges, Wormhole and AnySwap. Connects is like a liquidity layer, but I think when we turn to like the question of like what is the spectrum of like secure or like insecure to secure, I always like to start with IBC. I think in particular at Nomad, all of us are, one, we're like Cosmos fans, but also IBC we think is kind of the pinnacle of where interop at least should be in the very far future. I think you kind of have to give credit to Cosmos for like they saw that we'd live in a multi-chain world very early on, and kind of while these conversations around like the killer L1 were like going around, they knew that like heterogeneous scaling through like several chains and like providing a shared communication layer was the way to go. And so the only limitation is that it only works for Cosmos SDK. Essentially, like they run what Cosmos SDK is built is like IBC, and that is this like light client module that basically allows any Cosmos SDK chain to communicate with another one by forwarding block headers, and then within that block header you can prove any state under the like state root. If that were possible everywhere, by all means that should be like what we use. It is the most like trustless version of bridging we have, but unfortunately with this like L1 race, you have all these different protocols, and they don't speak the same language. They have different consensus mechanisms, and that's kind of where we are. So like in the absence of IBC in all these places, that's kind of where trust minimized bridges come in, which is the whole spectrum, as you said, like AnySwap, Wormhole, Nomad, Axelar, like all these bridges that are kind of locked into this race right now. Like that's the space that we try to fill, is like where IBC does not exist. Like how can we still provide the next most trust minimized version of that?
Gotcha. That's interesting. So I guess like what your guys' focus on is the trust minimize, and that makes a lot of sense because we've seen a lot of hacks in the space as well. So curious, like how have you guys approached minimizing that trust, like on the layer? Like a lot of times it's really I've seen some of these places they like out some of these other places they do like basically just send the data directly from one chain to the other, and then like some type of storage mechanism for that, or I'm actually not sure if some of them started moving to more of a consensus-based mechanism. So kind of curious like how you guys kind of approach that relayer network itself, to minimize the trust there.
Oh, sorry, you cut out for a second. I think you're back.
Oh, sorry.
Yeah, I think I got the question.
Okay, cool.
Yeah, so yeah, I mean, as you said, like the first bridges were centralized, like kind of just storing information in some locked away like database. Like the best example is probably like WBTC. Like people wanted to bring Bitcoin to Ethereum. The tech wasn't really there to do anything like a trustless relay. And so like WBTC is just like a central party saying like, we'll lock Bitcoin and mint representations on Ethereum. That's like step one. I think step two was like, as you mentioned, we have like Wormhole and AnySwap. Those are essentially multi-sig bridges. So same idea, just like add a couple more parties and require some like minimum number of them to like agree on some cross-chain event that happened on chain A and like post that on chain B. Then I'm just kind of going through the evolution to like set the stage here, since you asked like, where are bridges going from like centralized and like how are they moving forward?
Yeah, that'd be really helpful. Yeah, thanks.
Yeah, so kind of like after multi-sig comes like validator-based bridges. It's essentially adding like economic incentives to not act maliciously to the multi-sig model. It's like essentially you'll run a chain, like a third chain, and you'll have like probably a proof of stake chain. That chain will come to consensus on events on chain A, post those on chain B. If anyone in this like third party chain acts maliciously, then their stake gets slashed. And so it's like essentially you can think about it as like the multi-sig model, but with slashing and like consensus. The last, obviously, like we have IBC, we have validators, but like there's a gap in the middle, and that's kind of where we put Nomad. Nomad is essentially it's very similar to optimistic rollups. I don't know if they've been like covered in another video. Maybe you can let me know.
Yeah, maybe you could go into optimistic rollups a little bit. I think that would be helpful. Yeah, just for some of the newer people. Yeah, that'd be helpful. Thanks.
Sure. Yeah, just as like a super high level, like in order to, as a way of scaling Ethereum, you'll have like a sequencer that runs off chain. Its only job is really people will send it transactions, and it will take those transactions, perform the computation on like state, and then produce an output, and then post that commitment to an output on chain. And then once that like commitment is posted, a fraud window will open, and within that window, anyone is able to provide a proof that either that computation was valid or invalid. And so Nomad is quite similar. We have, let's just say an event happens on chain A, we'll have a bonded like notary called the updater. It'll sign like, essentially, I'll back off a little bit. We have like two contracts that live on both chains. We have a home contract on the sending chain and a replica contract on the receiving chain. And it's basically, it just facilitates the passing of Merkle roots, so like passing of state. And so we'll have a bonded notary called the updater sign these Merkle roots. That's basically an attestation to all the events and state on this chain. We'll post it on the other chain, and then we'll start a fraud window. And within that fraud window, we'll have a set of watchers which can provide a fraud proof and say that this attestation to this state is incorrect. And so it's very similar to an optimistic rollup. But I think to compare the models, like we start with centralized bridge, that is like a one-of-one honest actor assumption. There's one party you trust. If you trust that that one party is honest, then it's secure, but otherwise it's not. If you go to a multi-sig, it's kind of like a K of n assumption where you have n number of like people in a multi-sig. As long as K of them are honest, then you're safe. You move on to validators, it's the same thing, K of n, but with slashing. But with Nomad, it's actually one of n honest actors, and that as long as there's one honest watcher out of the n watchers to flag fraud, then you can consider your fund safe. And so we kind of move through this scale from insecure to slightly more secure. And then Nomad is probably, we believe it's the most secure besides IBC, where it's essentially fully trustless. So that's kind of the landscape, if that helps paint the picture.
Fascinating. Yeah, that's really helpful. Yeah, I love how you broke that down, because I think a lot of people aren't familiar with the whole evolution of items. So that's really fascinating. And then I guess like when you say you have watchers watching it, like how do you verify that this is fraudulent or not fraudulent state? A lot of times from the watchers, like how could you maybe give like a more layman's term of just like that that process?
Yeah, so essentially what fraud would look like if you're the updater is like signing a Merkle root that isn't actually what matches the tree. Like the smart contract will hold state that occurred on this chain as long as you sign what's on that contract. That's valid, and then you can prove anything under that Merkle root. But the way you would commit fraud is if you sign some like random garbage Merkle root, post on the other chain, and prove something that never actually happened on the receiving chain. And so essentially, if you're the updater and you submit fraud, you're automatically slashed on the home contract. Like the home contract knows what state is correct, but the problem is telling the other chain that that was not true. And so you can kind of think about the model as like right now we have a trusted, like a set of watchers which are trusted at the moment, and they are the ones, if they see that fraud occurred on the home, they'll sign a message that says like disconnect the token bridge from the messaging channel because this attestation is incorrect. But really in the far future, it's a lot like optimistic rollups where right now a lot of the actual fraud proving mechanisms for optimistic rollups, like they're not actually out. I don't know where the state of things are now, but like the rollups, they definitely started at a state where like flagging fraud was a trusted process. And then they were still building out like the fraud prover mechanisms. And so eventually we'll probably get there, but for now we rely on a trusted set of watchers, which is still a more secure assumption, like to trust that there is one honest party in a set of parties. And you can also you can assign that watcher role to anyone. They don't actually have to be like, essentially, if you list an address as a watcher, you can give that key to anyone. So like you don't know who has the key and who doesn't. So you can't like bribe. You can't bribe people you don't know are in the set. So I don't know if that makes sense, but like essentially we're trusted at the moment. It's more secure still than validators, but the long run is to implement modules that actually can verify the state of the other chain trustlessly, which would require something more like what IBC does. But again, it's like I have to take steps to get there.
Yeah, for sure. Yeah, so you guys are kind of leaning on the whole optimistic rollup kind of research, and then like once that kind of is a little bit more fleshed out, you could just implement it on your kind of setup, right? Sort of thing.
Maybe not the specific research of rollups in particular, but the main thing is like if you want to prove that something happened on chain A to chain B, the only way to do it is to actually show proof of the consensus of chain A. So like IBC, this is running like a light client that verifies every single block and like shows that every single signer or every time a majority of the signers like sign off.
Oh, gotcha.
So like we could do that. It's just like it takes time, and it's like it's very custom per chain. And so kind of in the absence of that at the moment, we are kind of trying to do the next most trustless thing.
Oh, gotcha. So it's just like an engineering thing. You just need to build it out and then
Yeah.
eventually be ready. Oh, okay, gotcha. Makes sense. Okay, that makes sense. Very fascinating. Okay, interesting. Yeah, and then I guess, do you see any like potential vulnerabilities with this approach still? Like any specific areas that you think maybe in the future you guys could go and like address, but it's not like a big problem right now, or like just any vulnerabilities you kind of see with this approach? Yeah.
Yeah, I think I mean, one, expanding the watcher set is one thing that we're working on, and like won't reveal too much about like the parties we're working with specifically, but we're trying to obviously bring on reputable people that can essentially serve as watchtowers for this chain. The vulnerabilities that you run into are like, let's just say like during the fraud window, like if you're using like Alchemy and Fiera and like whatever RPC endpoints are out there, if they all happen to go down during the fraud window such that you can't submit a fraud proof in that time, then obviously that's an issue and that's a vulnerability. But it basically, certain liveness issues like that become vulnerabilities. But again, like the hope is that hopefully all of the RPC providers don't go down at the same time. There would be much larger problems if that were actually the case for more than just Nomad. So
yeah. For sure. Yeah, makes sense. Yeah, makes sense. I guess like you could just have different watchers use different ones and try to like require different as many different types over time.
Yeah. You can also run your own node as well.
Oh, right. Yeah. Just
yeah.
your own local node if you can trust them to keep uptime. Yeah. Makes sense. And then I guess like you mentioned some of the slashing mechanisms that earlier kind of bridges implemented. Are you guys thinking of implementing something like that to like reward or disincentivize certain watchers or things like that in the future, like with some token slashing? Yeah.
That's a good idea. I mean, it's a good point. And I'll say the updater will be bonded. That's kind of trivial. I would say the slash bond will probably go to the watcher. Again, we haven't like fleshed all this out per se immediately, but like some ideas are like that bond will likely go to the watcher that, or like some of the watchers that ended up flagging the fraud on the receiving chains. Another thing is like to enforce that watchers actually take action is that we want them to, like, you can also bond the watchers as well and say, look, if fraud occurs on the home contract and you didn't sign a message that said like an attestation that said that happened to be put on the receiving chain, then you can also slash the watcher as well. It gets a little more complicated, I think, incentives wise, but it does make sense as a way of like maintaining watcher or like enforcing watcher uptime. So those are two ideas. But I think overall, like plans to expand the protocol in a way where it's like a self-sustaining thing is like, it's definitely in our like vision for sure. But I think right now in our immediate roadmap, like for the time being, probably won't be on it for now. But
gotcha, for sure. Okay, for sure. So like bonding for updaters or watchers will be like a future item. Or
actually, no,
like
bonding in particular, that is actually on our roadmap. Like that's also quite trivial there.
Oh, okay.
I was more talking about like incentives for like, say, if you want to be a relayer, like such that like, so there's certain roles like relaying messages and processing them where anyone can do it. But like right now the Nomad team is running those. But if you wanted to say like, have some incentive for like anyone to be able to do it, like we haven't baked those into the protocol yet.
Gotcha, makes sense.
But those would probably be farther out. But as far as bonding and like the economic security ones, those are definitely like closer in our site, I would say.
Gotcha, cool, that sounds good. And then yeah, that's really fascinating. And then I guess like with this approach, I'm guessing because you have the fraud checking mechanism, the transactions won't be finalized immediately, right? Like I've seen some of the stuff like on layer 0 and stuff, it seems like they're finalized almost immediately, which kind of makes me a little worried sometimes. And so I was kind of curious your thoughts on that, like what the approach is, or is that even the case, like what I'm thinking of?
Yeah, I'm not, like I've read the layer 0 paper. I haven't read too much about like Stargate in particular. But when you say like the things are confirmed instantly, what exactly do you mean? Like, what does that look
Yeah,
like?
like if you move, I correct me if I'm wrong, but I thought I saw when I was testing out Nomad that on with the connects, like there was an option for that. It when you use Nomad, you move it from one chain to the other chain, and you have to wait a certain period of time before your funds are actually finalized and you can withdraw them on the new chain, right?
Mhm.
On Stargate, which uses basically layer zero's relayer network, it's immediate. So like once you drop in the USDC, or almost immediate, I mean, maybe like a couple second delay or something, you drop it in, and then immediately you can go to the next chain, confirm that, and then just pull out your funds like less than 30 seconds, I would say. So that's sort of is that the case that you need some time for Nomad, and that kind of increases the security and allows a fraud mechanism?
That's interesting. I think at a bare minimum, you gotta wait like the time it takes for the sending chain to come to finality. So for Ethereum, that's something around, I guess we've set that to like 15 to 20 blocks. So I don't know how you do it in 30 seconds, but
Oh, okay.
maybe,
Yeah, I
maybe.
guess like it's not like maybe the timing is a little shorter than I thought, but
Mhm.
usually for faster chains, so they have it like on Avalanche and
Yeah.
Polygon, or yeah, so
Mhm.
like not as long as Ethereum. But I'm curious, like, is that longer time for Nomad because of the fraud checking
Oh
mechanism, or
yeah,
is it because?
absolutely. Yeah.
Okay, gotcha,
Yeah.
for sure. Mhm.
Yeah, the fraud window is parameterized to 30 minutes
30 minutes.
right
Okay,
now.
gotcha.
So yeah, that is to allow for time for if there is fraud for a watcher to pick up that the fact that the fraud has occurred and then like post that on the other chain. Yeah.
Gotcha. Okay, cool. So I guess there's like a trade-off, like, but this is more secure, less likely to get hacked, but it's slightly slower. But I think that slower bit of amount of time is totally fine if people are moving like larger amounts of transaction, they probably want to use
Yeah.
like
Yeah,
Nomad over
exactly. I
layer
think
zero.
that's
Yeah.
what you picked up there is like kind of the crux of like what the way we've been thinking about this is um, if you're moving a large amount of funds and like we all know that one day like bridges will hold some insurmountable amount of funds like we think we see like some 9-figure hacks today like those could potentially look small like there aren't even that like comparatively to what there will be like there are not that much funds in these bridges today and like if you're going to be moving a large amount of funds like we assume that a 30-minute wait time is an acceptable trade-off if you care about your like couple $1 million. Yeah, so that and like another thing that we've been eyeing is cross-chain governance. Maybe I'm getting ahead of myself, but so Nomad is like it's an arbitrary messaging passing protocol. There's kind of like two layers. We have like the core message passing layer, which is at its roots just like passing local routes between chains. And then on top of that, you can build applications. So like we built our token bridge on top of the messaging layer. Um, where was it going with this? Remind me.
So I guess like what you were kind of explaining was we started with sort of the finality times between
Oh, I
like
was talking
layer
about
zero and you
governance.
guys.
My
Yeah.
bad. Sorry. Yeah.
Oh no.
So the thing with governance is, yeah. So like, because we can pass arbitrary messages, something we're also interested in is like, think about like high value packets. Like a large transfer of tokens is one example, but if you're gonna like forward a governance decision across chain, like you presumably can wait more than like 5 minutes for that to happen. It's like a big thing as well. So um, I guess we're targeting use cases where like the latency is acceptable and like the value of the packets you're sending is high enough such that you can wait the 30-minute like timeout window. Yeah.
Gotcha. That makes sense. Yeah. Fascinating. And then I guess like would you guys still run into the whole issue of like the honeypot issue where, layer zero has like 4 billion TVL locked of like stable coins on there? It's like kind of large. Like would there still be people holding like a certain amount of tokens on one side and then a certain amount of tokens on the other side to transfer across? And could that introduce like honeypot, like basically be a honeypot for people to try to hack that pool of
Yeah.
token?
Yeah, that's a good question. I think because under the hood, I'm not totally clear because I don't know too much about like layer 0 and Stargate in particular, but from what I understand is like Stargate, they use existing like quote unquote native representation, like they use the canonical representations of assets. Like that's what you get as an end user. But if I'm not mistaken, under the hood, like they still use like a generic message passing layer to like mint a version of like the like maybe Stargate and layer 0 token, like that's like one-on-one tradable with these native tokens. So in essence, yeah, I mean, there's still funds locked in the contract. For us, like funds are escrowed in the token bridge. And like, yes, for any kind of like mint and burn bridge, like this honeypot thing it's kind of unavoidable. But as long as the underlying mechanism is secure and that you can't like, rug people and like steal from the honeypot, then, obviously you're good. But clear that the space has a ways to go. And like, yeah.
Gotcha. Makes sense. Yeah, I guess that makes sense. It's also interesting if like I've heard like some people talk about the implementation where you use a native token and you only bridge the native tokens and then just list liquidity pairs against that native token on all the different chains. So essentially, if they want to move USDC from one chain to the other, they would just trade it for that native token that the bridge controls, and then they just do whatever they need on the other side for that native token, and then do a swap on a new DEX on that other side. But it could be introduced like some types of slippage and fees and for like connecting the DEXs on both sides. But yeah, I thought that then you wouldn't have like the whole like kind of pool of stablecoins. I heard some people brought that up before, but I'm not sure. I haven't seen people do it yet that much, so I'm not sure how well that works.
Yeah. Well, I mean, you did mention Connects was a good example. Like, I think they may be similar to what you're describing, and correct me if I'm wrong. But they're kind of like a liquidity network where you have like, or maybe you've used them before, but like you have LPs on one side, you like essentially release tokens on one side, give it to LP, the LP will unlock their tokens on the other side. And like you basically just trade, like swap tokens, essentially. That is that kind of what you're referring to?
So I think that's most of the approach that most people use right now. Like Connects uses that. Stargate actually uses that as well. There's like pools of stable coins on like every chain that they support. And that I was just thinking, is that approach, or is another approach like basically don't even have these pools, just have your own native token that trades at a certain spot price on DEXs, and then just have a bunch of LP positions on DEXs for your native token on all these chains. And then on the bridge itself, it just moves native tokens and then swaps it out on a bridge. So like in the user's perspective, if they want USDC on, and then they want, let's say, Ether on the new chain, so the bridge itself would just make the trades automatically on the bridge. So it aggregate all the DEX prices, make the trade for that native token, and then the bridge would just bridge the native token over and then make a new trade on the other one. I haven't seen anybody do it yet. I'm not sure if that would be one, a security improvement, and two, would it like, it seems like it'd be a lot of slippage as well. So I'm not sure if it's actually better,
believe
but I've heard some people bring it up. Yeah.
Have you heard of Lee Finance by any chance?
No. How do you spell that?
Just Li. I think it's Lee.fi. You'll find it if you just look up.
Oh, Lee.fi. Okay, cool. Yeah, I'll add it to the.
They're a bridge aggregator. Again, I'm not too familiar. I know Pranay, who's CEO at Nomad, did a panel with Philip, who's I think one of the founders of Lee Finance. But yeah, I think they do something similar to what you're describing, which is like they're a bridge aggregator, and I believe you can do swaps across chains like in the way you described. But you have to double check me. Maybe that'll be another video.
Gotcha. Cool. Yeah, that's quite interesting. Yeah, I was just kind of I heard it brought up like once when was talking with someone on bridges, but yeah, I'll check into that. That's quite interesting. I just pulled up their site. Yeah, quite fascinating. I guess like we're kind of coming up on time. I don't want to take up too much of time in case you have other things in the day. So yeah, I think is there anything that you want to kind of bring to your attention, like things that I'll definitely put a link to Nomad in the show notes so people can check out Nomad. Was kind of curious, is there anything you want to bring attention to, like people to check out on Nomad, or things that you're personally working on and things like that? Yeah.
Yeah, no, I think Twitter is good. I can send you
Mhm.
some stuff after as well. But
Okay.
yeah, I guess the last thing I'd say is just like I think it's
Yeah.
really awesome that you're creating content like this. I think for bridges in particular, there's definitely a big like educational aspect that is missing. I think when you're like a user, like a bridge, or there's like aping tokens across chains, like usually you're not thinking about security too much, and it's like as an individual user it often doesn't affect you until it like ends up rugging everyone, as we've kind of seen with like Ronin and Wormhole. So I think, yeah, I mean, education around this general topic, I think like what you're doing is great, and yeah, it's definitely something the space is missing, and would love to see more of it. So yeah, appreciate what you're
Awesome.
doing.
Awesome. Thanks, Luke.
Yeah.
Yeah, that's like really good ending point. Like just stay safe when people are bridging. I think that's a really good ending point. Yeah. And let me know. Yeah, I'd love to talk with you like maybe sometime in the future, maybe a couple months from now, like kind of update on things. But yeah, I really appreciate just you hopping on the chat, and thanks. Yeah.
Yeah, for sure. It was awesome chatting. Thanks.
Cool.
Nice meeting you, Stephen.